So working with undergraduates at Penn is actually a real joy because they come in very, very motivated and they're very, very hardworking. And so, and they also have, because they're so used to learning new things, I feel like they're very malleable and quick to learn. And so it's a testament to Penn students, actually, that they are like this.
So we had 6 or 7 different professors coming in to talk to us, and Jane Willenbring was one of them. And when she gave her talk, I was just instantly captivated.
I have a lot of research interests. I'm very interested in things related to the landscape, especially, so how the landscape changes over time. But then also specific forcing factors that cause the landscape to change. So for example, human impacts on the landscape is a big theme, as is the tectonic changes that the Earth goes through, and also climate change and how that changes the landscape.
My thesis is to use meteoric beryllium-10, which is an isotope of beryllium, to measure deposition rates into the Chesapeake Bay, so that we can figure out what the biggest contributors of erosion into the bay are today, because soil erosion is a really harmful process when it's in these unnaturally high rates. So what I've done is just to measure the beryllium-10 concentrations in the bay itself and in surrounding areas where we think are eroding, and compare those different concentrations to see where most of the sediment from the bay is coming from. The fieldwork that we did was so much fun. We went to the Chesapeake Bay area, like around Maryland, and took a bunch of farm field samples and stream bank samples. And this involved basically just like sneaking up on a farm field, taking a soil core real quick, like on the side of the road, and people would just like drive by the cars, like, what are they doing? Why are they holding like this big bowl planter wearing like boots? So after you get your soil samples, you bring them into the lab, and there's about 20 different steps you have to go through before you can isolate all the beryllium from your samples. And once you've done that, you end up with like a tiny little pinprick, like a few speckles of beryllium, and that's what you send off to the accelerator mass spectrometer to measure how many atoms are in your sample. It's a really, really trace amount. So for example, the numbers that we've gotten back are around 10 to the 8 atoms per gram of soil sample. And this is orders and orders of magnitude less than a mole. So you can imagine how small the amount. It's just been really fun, like being able to see this whole process through, like starting with the field work, going to the lab work, writing up my thesis and presenting my results. It's been a great experience, and I think that's one of like the awesome parts of Penn is like you have those opportunities to do that. And just taking on an independent research project, like Jane has given me so much freedom. Like I planned all the field sites, like she's helped me with the lab work, but it's largely been like me choosing where we go, like what we measure, how we measure it.
Undergraduate students have a great sense of independence and what they want to work on. And so that was definitely clear in what Shirley chose for her project. She had a good idea of what she wanted to do, and so I, in some cases, just stood back and said, go for it.